Hello everyone. So this is a project on statistical analysis and hypothesis testing, which is one of the most important topics and operations in the field of data science and analysis as well as machine learning. So this project is given to us as a part of the virtual internship program by AINEAI. Thanks to them for giving us such a enriching learning experience. So without further ado, let's jump into the main topic. So in this project, we have the main focus that we have to increase the year over year revenue from game purchases by increasing retention rate of gamers. Retention rate basically means that how long the gamer plays a game, like for 1 week or 7 weeks or a year, like that. So basically about the project involves working on data related to Cookie Cats, which is a hugely popular puzzle games like our Candy Crush or such games. As players progress through the levels of the game, they will occasionally encounter gates that force them to wait a non-trivial amount of time or make an in-app purchase to progress. In addition to driving in-app purchases, these gates serve the important purpose of giving players an enforced break from playing the game, hopefully resulting in the players' enjoyment of the game being increased and prolonged. But where should the gates be placed, and how the placement of the gates can retain the players for more time? So basically, there are two things. In this project, we require to perform exploratory data analysis, or EDA as we know it, of the given data set and generate the statistical summary out of it, and perform A/B testing between the two different groups of data to analyze the impact on player retention in the first gate in Cookie Cats is moved from level 30 to level 40. And here are the basic objectives of the objectives or exercises of the project, and let's move into the main part. So at first, like all other data science or machine learning operations, we have to import the necessary libraries and packages for our work uh, for our cut cut for our operations to go smooth. So we here import NumPy as NP, Pandas as PD, Seaborn and Matplotlib as SNS and PLT respectively, importing OS, and we are importing from scipy.stats, we are importing Shapiro, which will help us in hypothesis testing afterwards, and we are importing stats from scipy.stats, and we are importing ipython.code interactive shell and importing warnings. So now we are defining that our data frame as user underscore df, and we are using pandas.read csv function to read the csv file that we have directly from our local machine. Then afterwards that we will do what we will have to know what data types are present in the data set, what is the dimension of the data set, and we will preview the first 5 rows of the data set. So let's run it. Here we can see that the data types or data set, here we can see that 1 2 3 4 5, there are 5 main columns in the data set, that is user id, version of the game, sum of game rounds, retention in 1 day and retention in 7 days. So user id will be integer, version is object or string type, some game rounds is again integer, and retention for day 1 and day 7 is true or false, that will be bool. And shape of the data, that is the row as rows and columns. So the number of rows is 90,189 and columns is 5, that is 5 features. And here are the first 5 rows of the data. So the first thing we have to do is detect and resolve the problems in the data, that is missing values and outliers, etc. So at first we are identifying the missing values, because many things depend on the missing values, like in some cases, if the amount of missing values is over a certain percentage, then we have to fill them with the mean or median or mode values of all of the whole column. and in case there are in very less amount, we can drop the particular record, and that won't affect our dataset that much. So we are using the isNull function to get if there is any null values, and we can get it in a very much more summarized form. So as we can see that in no columns, in any of the columns, there are no null values present. Now we have to identify the outliers. Outliers are such values that are against or out of the general trend of our data, or that can hamper the normalized form of the data. So we will plot we will plot for to identify if there are any outliers in our data, and it will be again it will be the plot of sum of game rounds. So let's run it. Here we can see that there's a certain value that is very much out of the normal trend of the data set. So let's point out the value. Which one is it? We can see that this one is the outlier value. So we have to point out the index of the outlier, and we have to drop that so that we can normalize our dataset once more. So we are assigning the user in the indexes of the data frame to the index variable, and we are using a condition that is in sum of game rounds user in the data frame user df, the max value. We will select the particular record in sum of game rounds with the max value of sum of game rounds, and we are assigning the outliers variable as index, that is the index of that particular row with this particular condition, and we are printing the outlier. So the outlier record is at 57702 index. So now we will drop normally drop the outlier user df.drop, and now we can run it once again, and now we can check it if the outlier is present anymore. And as we can see, there is the data set has got back its normalcy, that is there is a general trend present in the data. Now we have to plot summary statistics and identify trends to answer basic business questions. So here we have to first know that what is the overall 7-day retention of the game, which is a very important parameter. So retention we are creating a variable retention rate 7, and we are assigning the column user df retention 7 dot mean into 100 to get the retention rate, average retention rate. Now we are printing it, and as we can see that the average 7-day retention rate of the game for both the versions, that is where the gate is at level 30 and gate is at level 440, the average overall retention rate for 7 days is 18.6055%. Now, how many players never played the game after installing? There are many people many people who install an app or a game and may not play it afterwards. Just download it only because they like the preview or so. So we have to find out those people who have downloaded the game or installed the game but never played it. So let's run the code, and we can see that 3994 people never played the game after installing at all. Now, does the number of users decrease as level progresses, highlighting the difficulty of the game? So let's run the code. We are grouping by the sum of game rounds played, and we are seeing that after first 200 game rounds, if there is a decrease in the number, and there is a decrease in the number of users, and we can by that we can observe the difficulty of the game. So we run this, and we can see that there is a general trend that after installing the game up to a certain game rounds, it follows a steep path, and it's steep slope, and there is a high amount of users, and after that certain level the number of users constantly decreases. So we can say that at about this point or along this slope there is a difficult point, after which users are affected by the difficulty also. Now we have to generate the cross tab for two groups of players, that is game version 30 and 40, to understand if there is a difference in 7 days retention and total number of game rounds played. So let's first find out 7 day retention summary of different game versions. So basically crosstab summarizes the whole thing inside a table. So we are plotting the crosstab user df in and the version column against the retention of the 7 days column, and we are applying the condition that r by r dot sum, that is the retention rate we will get back, and we are using lambda because we don't want to get any we don't want to create another variable. We just want this formula to return the value, and we will directly apply it, and we are using axis is equal to 1 because we want the columns. So let's run it, and here we can see the result. And as we can see from this, that though there is a very minimum difference between the values, but the version gate 30 has a higher 7 days retention rate than that of the gate version 40. Though there is very slight, but there is a difference. Now we have the game rounds. We have to get the game round summary of different game versions. So we for different game versions there are two versions, so we are grouping by the versions, and we are getting the game rounds aggregate of count and mean, that is average. And here we can also see that the total number of game rounds played by each player differs slightly based by the game version. Though the total number of game rounds for version gate 40 is more than gate 30, but the average game rounds played for gate 30 is a bit more than gate 40. Now we have to perform two sample tests for groups A, that is the version for gate 30, and B, group B, that is the version for gate 40, to test statistical significance amongst the groups in the sum of game rounds played, that is if groups A and B are statistically different or not. So we have to do some initial data processing, that is we have to separate them in two groups. So we are using the user df, the version column, numpy.where is a function we can locate using now user df dot version is equal to gate 30, that is if where the user df dot version, where the game version will be gate 30, it will be assigned to group A, and where the condition would not satisfy, the that version will be assigned to group B, and we are simply specifying that here too. And let's run it. Now we have to perform the Shapiro test of normality. The Shapiro test, or the Shapiro-Wilks test for normality, is one of the three general normality tests designed to detect all departures from normality. Now what are the other two tests? There is Anderson-Darling test, and there is the skewness-kurtosis all test. Now the Shapiro test rejects the hypothesis of normality when the p-value is less than or equal to 0.05. Failing the normality test allow you to state with up to 95% confidence that the data does not fit the normal distribution. Passing the normality test only allows you to state that is no significant departure from normality was found. The Shapiro-Wilks test is not as affected by ties as the Anderson-Darling test, but it is still affected. The skewness-kurtosis all test is not affected by ties, and thus the default test that we perform. So what we are doing here, we are creating two variables, that is normality of A and normality of B, and we are doing here that Shapiro of group A if is less than 0.05, Shapiro of group B is less than 0.05, and we are stating and leaving just like that because it will return us a bull value. And in case the values return true as a result, that means that the null hypothesis, that is H0 distribution is normal, is false for any of the cases that returns true. And returns true, that means that hypothesis null hypothesis is proven false, or alternately we can say that alternate hypothesis h1, that is distribution is not normal, is true for the groups. So let's run it, and normality of A returns true, that means that the null hypothesis is rejected by the Shapiro test. That means the alternate hypothesis is true, that is the group A is not normal, and the normality of B also returns true, so we can verify that none of these are normal. Now we have to test for homogeneity of variance. Equal variances across samples, here the groups, is called the homogeneity of variances. Some statistical tests, for example, the analysis of variance assume that variances are equal across groups or samples. The Levine test can be used to verify that assumption. So what we are doing here, we are creating a function, that is Levine test. We are assigning three variables: data frame, group, and target. So we are taking the values of normality of A and normality of B from the Shapiro test, and we are saying that if normality of A is equal to false and normality of B is equal to false, Levine test is equal to stats.levine group A comma group B, and the total thing is compared with 0. If it is less than or greater than 0.05. If Levine test is false, we get one set of values. If Levine test is true, we get one set of values. Now we are specifying a dictionary here, and we are assigning the keys and values here, what we want as output, and we are specifying the columns so that we can summarize it better. And let's run this. So now we are calling the Levine test function here. Data frame is our user underscore df, group is the version, and target is sum of game round. So let's run it, and as we can see that A/B testing hypothesis, h0 is equal to A is equal to B, and h1 is A not is equal to B. Test type is non-parametric. A/B hypothesis gives us the result rejected, because we have a p value of 0.0254, and the comment is A and B groups are not similar, therefore we reject the null hypothesis. Now we can do another test, that is the test of significant two sample test, or here it is two sample t test based on the conditions. The two sample t test is used to determine if two population means are equal, that is here two groups. A common application is to test if a new process of treatment is superior to current process of treatment. That is, in this case we can say that if the gate level 30 is better or the gate level 40 is better. So here we can see that, like before, we have created another function that is for two sample test, and we are testing if normality is false and normality of B is false, then we are assigning this value, and if this value is false, this will give the t-test value of this, and if the two sample test value is true, then this t-test will get the value of this, else we will get the t-test value of this. And we are assigning the values to the temp data frame, and we are arranging the results in a bit clean and a tabular form, and we are trying to print and returning the temp data frame here. Now if we run it, we can see that the AB hypothesis again is rejected, and the p-value is same here too, therefore we are rejecting the null hypothesis here. Based on the significant results, if groups A and B are statistically different, which level has more advantage in terms of player retention and number of game rounds played? So we are doing user df retention of AB, user df group by version, aggregate user ID will be count, retention 1 mean, retention 7 will be means, sum game rounds is sum, and we are calling up the user df retention. And as we can see that these are the corresponding values for the different game versions. Though there is a little bit of difference in the sum in both of the game versions, and we can see that the game version 40 has a little bit higher number of game rounds than game version 30, but we can see that the 1 day retention rate for the gate version 40 is a tidbit lower than the gate version 30, very low. Also, this case is the same for the 7 day retention rate, that is the game version 30 has a higher retention rate. By simply observing this, we can say that the 1 day retention rate for the version with gate at level 30 is higher, and it is also able to retain the user till the 7 till the and it is also able to retain the user till the 7th day as a little bit more successfully than the version with gate level at 40, as we can see here. So the company should definitely not change the gate level from level 30 to level 40 permanently. Now for a bonus question, we have to use the bootstrap resampling, plot the retention rate distribution for both the groups in order to visualize the effect for different game versions and the game retention. So we are creating two different lists, and we are assigning these corresponding values to the lists, and we are plotting the values corresponding to them here. KDE plot, let's run it, and we can see the results here. Though there is not much difference between both the game versions, but we can observe the number based on the number of samples, we can see the difference in the retention rate by following the x-axis here, and we can clearly observe that there is a significant amount of difference in the retention rate distribution in both the cases for 7 days and for the 1 day retention. So the same results that we observed here in the user DF retention data frame, we can observe here too, though the value is very less, but this is very much significant in case of business analytics. Now let's plot it in a different manner again, and we are plotting retention of 1 day, difference of 1 day and difference of 7 days here. So let's run it, and we can see that the difference between the two groups, that is the 1 day retention rate, has a significant amount of difference between A and B. That is, A, of course we have seen that A has a little bit higher value and B has a little bit lower value, but in case of 1 day we can see the difference much more clear way, in a much more clear way, rather than in case of 7 days, though there is a difference present. From these charts we can see that most likely percentage difference is around 1 or 2% for 1 day retention. For 7 day retention, the most likely percentage of difference is around 2.5 or 2 to 5%. Moreover, the most of the distribution is above 0% for the in favor of a gate level at 30. Now we have the probability that 1 day retention is greater than when the gate is at level 30, and the probability that the 7 day retention is greater when the gate is at level 30, and this will give us much more confidence about our results. So let's run it again, and we can see that the probability that 1 day retention rate is greater when the gate is at level 30 is 95.8%, whereas we can fully assure you, that is 100%, that the 7 days retention rate is greater when the gate is at level 30. So the bootstrap results above can tell us that there is a strong evidence that 100% probability 7 day retention rate is higher when the gate is at level 30 than when it has level 40. The conclusion is, if we want to keep the retention rate high both for the first day and the 7th day, we should not move the gate from level 30 to level 40. There are of course other metrics we could look at, like the number of game rounds played or how much in-game purchases are made by the two groups, but retention is one of the most important metrics in case of business in the long term. Special thanks to AINEAI for giving us such a wonderful project to work on. We got to learn a lot about statistical analysis and hypothesis testing, and we got to clear our statistical concepts here as well, and got and got to apply it in a very interesting business problems. Also, if you have any questions or doubts, mention it in the comment below. I will make sure to get back to you, and the code of the project will be mentioned in the description box. Thank you.